I know like it's a bit late for some of you, so I will make it quick. What I wanted is just to make sure that you understand the topic of machine learning and once you put it into production, right? So whatever you heard today and previously about machine learning and how you can use various technologies is going to change now, because we're going to talk not only about how you can detect anomaly for logs, for example, for this use case, but also how you can take your application and actually scale it in real time. So my name is Fawaz Ghali. I work for a company called Hezecast, which is unified real data platform, which allows you to do stream processing as well as fast data store in one platform. And this is very important because we're going to talk about mission critical applications today. There is no way for any of us actually to write such application at scale, at the same time make sure that you minimize latency. But before I start, anyone can guess who are these guys on the screen here? Here you go. Yes, that's correct. So these are the Beatles, right? So I flew in from Liverpool yesterday, and every time I talk about stream processing, usually people assume we're talking about music streaming or we're talking about video streaming, and this is not accurate. Stream processing actually everywhere. Now, if I ask you, take out your mobile and check whatever app you want to check, the chances are 8 to 9 apps out of 10 are using these concepts. We're going to talk about it today. So this is very important. So not as a developer or DevOps, but also as end users. Usually you want to understand how things work in real time. And it is very important because we're going to talk about fast applications, right? If I ask you now, go and write a log application to your application or to your microservice, you might be able to plug in a specific library and you can get away with, for example, log4j, and you can do some logging mechanism. But that's not what we're talking about today. We're talking about fast events. Anyone wants to guess how long for an eye to blink? Yeah, it's like when you blink, how long it takes?
10 milliseconds.
Here you go. No, it's actually slower than 10 milliseconds. It's about 1/3 of a second, so 350 milliseconds on average, depending on age, sex, and so on. So this is pretty fast, right? If you want to write such application and you want to scale it, you should be able to minimize latency. And this is a problem because if your data center is located in the US and your microservice is located in some data centers in Italy, there is a network hoops, a network delay between your data center and your microservice, and which you can't change, right? What you can change is your infrastructure. So every time you write a log message, you want to be able to actually minimize all aspects of data storage and all aspects of stream processing on your logs, right? Because we want to predict what's going to happen for your application in the next moment. And this is very important because the problem is not in analyzing logs, it's actually in detecting anomalies or where spikes happen in your data. Now, if you have 1,000 transactions or 1,000 logs messages, you might be able to process it, right? You might be able to know how you want to detect and which machine learning model you're going to use. But the problem is nothing works like this in real life and in production. If you check, for example, big events online, such as Black Friday or Christmas offers and so on, things go haywire. And every time I mention scaling, I sometimes hear like, hey, yes, let's just use auto-scaling for this microservice or for this class or for this Python or machine learning model. And auto-scaling is not the right answer. That's why sometimes you go online, whether it's on your mobile or your laptop or desktop, and you can't get to the service. You can't access your favorite website, or you can't access your favorite microservice and so on. And this is not relevant to auto-scaling because auto-scaling is enabled and the website or the microservice still crashes for whatever reason. So this is what we're talking about today. How can you take a normal application, normal log analysis, and scale it at speed and with minimized latency, which is like roughly around 100 milliseconds or less. Okay, so let's just work out the algorithm here, right? I'm sure you've seen such architecture before or such algorithm before, maybe today, maybe somewhere, I don't know. But let's just go about this architecture, how to work. You need data source, obviously for your model or for your microservice. And this data source could be considered as batch source, right? Where are you gonna store your log messages? Maybe in a database or maybe on a S3, for example, on AWS or file system and so on. And from this data set, what you can do is write your machine learning model. And I will explain why you shouldn't basically try to optimize your machine learning model. So you choose your model and you feed it into the data set, you train it, and you take it and put it into production on whatever platform or cloud provider you want. You would assume you will get results, right? You would assume it will work as expected in real life scenario as in training. And this is not a reality here. Even if you wanna do it this way, just make sure you're able to detect an anomaly where things go haywire or go out of context, regardless if you're using it for log messages or not. So let's just describe it quickly how you should do it. And if you're coming from data architecture background, this is helpful to understand how you can develop such application at scale. So here we have on one side, log messages coming in a stream. This is very important. And I will explain why you need your log messages to be in a stream, not in a database or on hard drive. And you ingest your logs. Usually you attach some information, right? So for example, IP address, timestamp could be relevant to which microservice you're using or which application you're using. And then you need to do data enrichment, which is something unique in the sense that not many applications are actually able to do the data enrichment. So for example, if your application is going to crash, do you know the reason why? And this is important, right? So are you running out of memory? Or is your CPU overloaded? Do you have enough disk space or not? Do you have enough bandwidth or not? So many questions can change how you want your model to behave in real time. And of course, the data enrichment will help you to understand the logistics. You need to do data transformation, and this is not relevant to batch feature engineering. We're talking about real-time feature engineering, and I'll explain what it is. And then you can do the prediction. And based on this, you can say, this is my machine learning model, and this is my data set, I trained it, and this is my output. Anyone can guess how long it takes for this operation to be complete? Come on. It's very easy. We're talking seconds, minutes, hours, seconds. Milliseconds, yes, that's correct. Not really, no. So it takes milliseconds. So who answered here milliseconds is correct answer because banks usually, or finance, or online stores usually follow the same architecture, and there is an SLA or time window they need to respond. So even if, for your example, you check your mobile now, and the app is not responsive, you're gonna change to a different app, and this is physically not possible to do it in milliseconds, but it takes milliseconds. So you would assume switching between apps, you actually it's gonna take you a few seconds. That's not correct. It's gonna take you less than 1 second. And obviously, if you wanna scale it, you're gonna need some kind of data merge. And this is very important to actually have it in practice. So I'm gonna explain what it is now in this architecture, and you should be able to replicate this work here. So in simple terms, you need two data sources. So My advice to you, if you want to play with this concept, which is real-time stream processing, take your application, take whatever use case you're working on, and try to feed into it two different data types. So first data type is real-time data, and this could be coming from Kafka, for example, or could be coming from Apache Pulsar, AWS Kinesis, whatever. And the batch data. Batch data is what we know, right? It's database, for example, or file system, and so on. And you want to be able to actually process both at the same time in the same speed, right? And this is where you can actually detect anomaly in your logs. So I will show you now a stream of logs which doesn't have any context, and at the same time I'm gonna feed into it different data stream, which is batch data, to provide context into it, and your application only then can analyze it. It's very important to understand this data analysis is not normal, because we're gonna analyze data before we store it into database. So this might be new for some of you, or might be a strange concept. So if you ingest your data into your application, we need to process it before we store it into database or a file system. So let me show you quickly how it's done. But before this, let's just see about the time decay. Why you need to care about this application, right? Why you need to change your architecture. It's a very simple concept called time decay, which means you lose value the longer you wait on your data. It doesn't matter if you use this concept or not. It doesn't matter if you do machine learning or not. If I ask you now, what did you do last week? You might be able to remember. If I ask you what you did last month, you will struggle a little bit because the information itself lost some value in it. Of course, you need to do it in real time. So I'm gonna flip screens quickly to show you how it works. So if I want to analyze, for example, even numbers, so if I have stream of data, it doesn't get any simpler from this. So if you want to take some screenshots, do so now. And I just want to actually apply windowing on my data and filter whatever I want. In order to do this, I need a framework for it. So if you are a Java developer, so you understand this code, don't worry if you're not. I have some code in SQL and Python, so I will explain it in different way. And in here, what I have is I have Hazelcast running locally on my laptop, and I'm gonna create pipeline. So in your case, what you need is to actually merge your application or your microservice into this pipeline. The pipeline itself is very easy and straightforward. I have data source. I'm gonna apply a timestamp into it, and then I'm gonna do filtering on it. Of course, I'm gonna send some results here. So this is as simple as possible. So you have a window and you want to do data analysis on it. Now, if I run this application now, it will start a cluster on my laptop. And as you see, these results, now it appears 62, 60, 70, 80, 84, and so on. So only even numbers. So I will get some question now. Okay, I can write it in, normal for loop and if condition and so on. But you can't actually do it in real time. That's the difference between this concept here and what you actually implemented. And to make it even more challenging, if you want to scale your application, it becomes really a bottleneck in terms how do you gonna do it in sub-milliseconds. With this architecture, you see it on screen, you're able to do it in sub-milliseconds because there is a window and we try to process the data before we store it into database. Now, to go back again, I'm gonna show it in different way and how you can analyze your logs. But I just want to explain some concepts here so you can use it even for different architectures. So in here, what you see on screen is how you can build such solutions, right? You need one framework, and I will explain why one framework. And in this framework, you actually need to have a stream processing in it, which is very crucial when it comes to doing log analysis in real time. But also at the same time, you need to have fast data store. So this is considered as cache, for example, or some kind of in-memory grid where you store your data. And from there, you need to connect multiple sources, which is, by the way, you haven't seen it today. I'm pretty sure you haven't seen an application which has multiple sources to do one job or to do one machine learning model prediction. And this is crucial because most machine learning models actually are in production with multiple data sources. At the same time, you need to connect some clients, could be Python, could be Java, could be SQL. And from there, you can analyze your logs in real time and predict what's going to happen next. You don't need just your log messages. You need to enrich it. You need to add context into it. So some of you might be on this journey or have already started this journey, which basically it moves from batch to real-time machine learning, which is what we're going to do today. So you might be doing some ETL, for example, or you might be using some traditional machine learning, but you haven't reached to the point where you're using real-time machine learning. So what do we mean by real machine learning, or what is the difference between real-time machine learning and traditional machine learning? Any guesses? So traditional machine learning, usually you have batch features. You train your model on these batch features and you use the recent features to generate some prediction. So what is happening is actually you do prediction using batch sources. With the real-time machine learning, the story is different. You might use a batch source or real-time features to train your model, but at the same time you update the model in real time, which means you run it in multiple stages or you reiterate. That's why sometimes if you go to your favorite video streaming website, I'm not gonna name companies because it's being recorded. So if you go to your favorite video streaming website, sometimes even it is you who logged in on this website, you get weird recommendations, right? Something you might not have any interest in. Why do you get this weird recommendation if it is you who logged in the same account on the same machine or different machine? Because simply the machine learning model actually needs some time to adjust to the new features or new properties. Could be, for example, your location, your internet speed, weather forecast, and so on. And when you talk about your logs, you need to do something called data serialization. So if you haven't dealt with data serialization, essentially it's a way to transform your data. And this happens in multiple stages. So first stage is when you have different architectures could be embedded, so inside your application, or it could be in client server. You actually do it when you read your data, when you write your data, or when you actually load it back into your application. So there are a couple of ways for data serialization and deserialization. If you use enterprise architecture, which means you have multiple clusters and multiple nodes, you also do it when you do balancing as well. So if I ask you now, how many transactions for serialization and deserialization you think for a simple put in a map? Anyone wants to guess here? If you have a map structure in your memory and you want to store some data in it, how many serializations, operations, and deserialization within this architecture? Just to put it in and read from it. This is very important if you want to actually serialize your log messages. So in simple terms, it depends on the option. So if you have option 1, which is basically 2 serialization and 1 deserialization, this is if you have the embedded mode, so your application or your method for serializing and serializing within your application embedded in it. And the second option, it takes 1 extra for serialization and deserialization if you use client-server mode. Okay, so this is clear. Now let's just jump how you can achieve it, how you can implement it. So I'm gonna tell you a story here because it's very important. Last summer, I tried to paint my house, right? And I took some time off from work. I spent 2 weeks trying to paint my house and the results was horrible. So I ended up hiring someone professional to do it for me and I got the results I wanted, right? So my takeaway from this message is don't do it yourself. So DIY approach, don't do it this way because it is a problem. Companies usually, of course, on your mobile, check whatever company you want. They invest billions of dollars on these solutions. They don't do it in DIY approach because there are some elements into it. So two ways to do it. So DIY approach, feel free to play with it. And essentially what you need data source or more to log your logs. So it could be, for example, you have Kafka, for example, as I will show you, or could be using Apache Pulsar, or you can use some kind of database. And from there, you need two frameworks. One framework for stream processing and one framework for fast data store. So you could be using Flink, which is great for stream processing, and you can use Redis for fast data store. So this is all good, but how do you actually go into terms of we actually look at feature online? So we want to do machine learning on this data, right? We want to be able to actually see what results we get. And in order to do so, how many of you heard of feature store before or know what feature store is? Just raise your hand, please. Couple of people here, so that's great. So if you use machine learning, you need to have feature store because you can't just train your model on set of features and use it for prediction. What feature store allows you to do is to store features and have different versioning, allow access control on your features, so you can run multiple machine learning models at the same time with different sets of features, right? So you have set of features and you have set of machine learning models. You can mix and match between the two. It is not possible to do it without a feature store. So from there you can do actual prediction in real time, so to decide what log message you're getting and what you need to do about it. So if you haven't realized yet, this will add latency, and this will actually spend more time to learn all these tools, and of course maintenance, right? Every time you have a new version from any of these tools, you need to upgrade. So one takeaway, if you don't care about any topics here today, is go back and check your application now today and see how many libraries are you using or how many tools are you using. If there is a chance you decrease number of tools, this solution, the new solution, will be much better than the old solution. If I ask you to solve a problem and you come up with 5 tools, before I look at the solution, I need to know if you can do it with 4 or 3 or 2. Why? Because we try to minimize latency. So banks, if you want to work in fintech, for example, there is no way to do it without minimizing latency. So this is crucial. So what you didn't hear about machine learning today, okay, it's on screen. What you didn't hear about machine learning today is you need 3 pipelines. You can't just have one pipeline in your Jupyter notebook to run a machine learning model in production. So what you need is to split it into 3 different pipelines, one for feature engineering, one for training, and one for machine learning inference or serving this model. And from there, you can scale your application or whatever you want to do with your microservices. So this is what most companies are following, this architecture. So if you want to write logs, for example, at detect anomaly, in these logs, you need to follow some similar architecture here. So we're running out of time. So I'm gonna run the code first and then I'll come back on these screens. I want you to see how it works in action. So those who are coming from data science background or machine learning background or used Python and SQL, this is what you need to do. So locally I have, let me see if I can increase the font size. So locally I have Hazacast instance running and I use SQL for it. So you see the SQL here. So what I'm going to do is to load my logs into my application here. So this command here is just SQL command to generate stream of logs. So if I paste it here and say I want all logs from a specific user, for example, I can type in this user and now I have all logs with all alerts I need, right? So you will see it running in real time. This is very important. It's not coming from database. It's not coming from file system, and it's not fake. Well, it is fake, but it's not like while loop or for loop. It's actually real events or real logs generated in real time. But it doesn't give me the option to know exactly what's going to happen next. So what I need to do is to do the data enrichment into it. So now I have one map. I'm going to create a new map to do data enrichment. So as soon as I paste this code, I'm going to create a new map with three features. I'm calling it feature 1, 2, 3, or extra 1, 2, 3. I'm giving it color. So in my case, I want to detect logs when the color is red. So I can simply go here and do join statement, simple join statement, which allows you to run machine learning in production in real time here. So actually, if I run it now, you will see the same log before, but now it's only when the message is red. So if you just follow this column here, if I stop it, it's still running, which means if I run this command again, it's still working in my cluster. So the cluster is running locally. You don't need to create it locally. Of course, you can create it on cloud. And my advice is to create such application on cloud, which allows you to track your memory and your CPU load and what you need in order to actually increase your cluster size and decrease. Okay, so this is one example. I know it's a little bit too much. So if you want to learn more about this concept, tag me online. You find me online. I'm happy to walk you through this one. But if you want just to scale your application, there are three ways to do it. One way is to use embedded mode, which means you run your code for log analysis inside your cluster. By the way, banks follow this architecture here. And the second way is to use something called client mode, which means you disconnect your client and server, disconnect your microservice for log analysis from your cluster. This is if you want to have full control on how you can scale the application. Of course, the third and best way is to combine previous tools. So hopefully this is helpful for you in terms of what you need to do for log analysis. Some of you might say, okay, tell me about which machine learning model I should use. Okay, there is no best model, by the way, and you need to use multiple or set of models because that's how things work in production, because there is no single machine learning model can predict any anomaly. If you look at the screen here, it's just example what you can use for your log information to enrich the log messages. You can do NLP, for example. And the second way is to do something called linear regression. Those who are coming from machine learning background know what linear regression is. Essentially, you map between values on the X with the Y to predict what's going to happen next. And the final part of this story is to do it in real time based on the cluster itself. So on one side, you see IP addresses with a score attached to each log message. And on the right side, this is where the linear regression comes into place, where it can detect. By the way, don't follow the linear regression. So this is just example here. As I mentioned, you need set of models running in real time, or you can use blue-green architecture. So you have machine learning model A or one running for end users and one as green running in background, and you keep switching based on whatever metrics you want to use. Obviously, the outcome or you want to have is some kind of alerts, but you don't usually use alerts. You actually send it to different Kafka topic, different stream, or you can send it to a second machine learning model. So hopefully this is helpful if you're interested in this type of topics. So this is community Slack, it's open source. So you can play around with the concepts. You don't need to use it only for log analysis. You can use it for any fraud detection, for example, any machine learning online recommendations or recommendations. I've seen some talks about large language models and similarity search. So same concepts apply. You always need fresh data for your application, and you need to analyze your fresh data or real-time data in either real-time or near real-time. So thanks so much for listening. Hopefully it was useful. Tag me online if you need some help or you want to know more about these topics, and we can take a few questions. Thank you.
One question.
One question.
Thank you. The most fast. Yeah, I'm coming.
You said that one of the key components of your architecture is a feature store. Could you give us some example of a feature store? Is something that you build according to your application, so it is a custom product? You have some example otherwise of a general purpose tool to do feature storing? What are you using? I mean,
Sure. So there are a couple of feature store online. So some of these are open source. So Feast is one of this, Feast. Why you need feature store for your data? All talks you heard today are using raw data, right? So for example, your log messages are raw data, are not features. So think about it as, for example, trades you're trying to place. This is raw data. You need to create features out of the raw data in order to use it to train the model. Usually, you take a time window. So for example, last trades in last minute or last 5 minutes or last 1 hour. But this raw data is the same. You can't reread the same data, raw data, in order to generate different features like 1 minute features, 5 minute features, and so on. So feature store allows you to store these features, so based on time frame, for example, 1 minute or 5 minutes, and you can reuse it. If you have multiple models, you can't again read the raw data multiple times. What you need is to use a feature pipeline to read your raw data once and use this feature pipeline to generate features in real time and store it in feature store. Feature store is just simple structure key value pairs. So x1, value 1, x2, value 2, and so on. And this will allow you to do versioning. So similar what you do for code versioning, you do it the same thing on your features, which allows you to track any changes for features when you want to run it in real time. So hopefully this is helpful. If not, tag me online, we can speak, or I'm gonna stay outside if you want to know more about this concept. Thank you so much for listening. Hopefully it was useful, and have a good weekend. Thank you.
Thanks to you a lot.